Hello viewer, welcome to Samuel Academy. In this video, I will explain more about the mole concept in chemistry. Let's begin. 1 mole of a substance has 6.022 times 10 raised to 23 particles. These particles may be atoms, molecules, or ions. This number 6.022 times 10 raised to 23 is called the Avogadro number. Molar mass. Molar mass is the mass in grams of 1 mole of an element, a compound, or a formula unit. It is obtained by adding the atomic masses of the elements in the periodic table in the case of a compound or formula unit. For an element, the molar mass is its atomic mass. For example, carbon, it is 12.011 grams. For a compound, the molar mass is equal to the sum of the molar masses of all the atoms in the compound. For example, calcium nitrate. Calcium nitrate, this 1 mole of calcium nitrate, it has one calcium atom, 2 nitrogen atoms, and 6 oxygen atoms. These 2 multiplies by everything here. So this 2 times n, that is 2 nitrogen atoms, and these are 6 oxygen atoms. To find the molar mass of calcium nitrate, that's the mass of 1 mole of calcium nitrate, we add the atomic mass of calcium, which is 40.08, plus the total atomic mass for nitrogen, that is, nitrogen is 14.007 times 2, plus oxygen is 15.999 times 6. So the total is 164.088 grams per mole. So 164.088 grams is the mass of 1 mole of calcium nitrate. We call it the molar mass of calcium nitrate in grams per mole. All right. Now, molecular mass. Molecular mass of a compound is the mass of 1 molecule of the compound. For example, the molecular mass of carbon 4 oxide, that is carbon dioxide, is equal to the atomic mass of carbon. From the periodic table, it is 12.01 plus 2 times the atomic mass of oxygen, that is 2 times 16 approximately. You will get 44.0 atomic mass units. So molecular mass is measured in atomic mass units, but molar mass is measured in grams per mole. Therefore, the difference between molar mass and molecular mass is in units. All right? Molar mass is measured in grams per mole, and molecular mass is measured in atomic mass units. What is molar volume? Molar volume is the volume of 1 mole of a substance. At standard temperature and pressure, 1 mole of any gas occupies a volume of 22.4 liters. All right? Standard temperature and pressure, that is S.T.P, means the temperature of 0 degrees Celsius or 273 kelvins, and the pressure of 1 atmosphere, or 1.0325 times 10 raised to power 5 pascals. That is the standard temperature and pressure. So we have seen that molar volume of a gas, of 1 mole of a gas at S.T.P occupies a volume of 22.4 liters. Alright. Next, let's look at the item called molarity. Molarity is equal to the number of moles per liter, or per cubic decimeters, moles per liter. So when you have a given volume, okay, in liters, the number of moles per liter is the molarity. For example, you have 0.2 m hydrochloric acid. This is the molarity of hydrochloric acid in this case. The number of moles per volume in liters. So if you have a solution of 0.2 m hydrochloric acid, it means that 0.2 moles of hydrochloric acid in 1 liter of solution. Alright? So this is what you have. You have a liter of a solution of hydrochloric acid with this concentration 0.2 m. Its molarity. Now let's say out of this solution you take 25 cubic centimeters and use it maybe in titration, practical. Then how many moles are in this volume? The number of moles in this volume will be 25 cubic centimeters changing to liters divided by 1000. Then multiply by 0.2 m for this acid. Okay, so the volume in liters multiplied by the molarity, you will get the number of moles in this volume. Alright, therefore number of moles is equal to the volume in liters times molarity. This volume in liters times the molarity, you get the number of moles in 25 cubic centimeters of 0.2 m hydrochloric acid. Now next, how to change mass of a solute into moles. Number of moles of a given mass of a solute is equal to the mass in grams divided by the molar mass. For example, if you measure 2 grams of sodium chloride, how many moles are in 2 grams of sodium chloride? You take the 2 grams you have measured using a precision scale. These 2 grams divided by the molar mass of sodium chloride, which is 58.44 grams per mole. Therefore, 2 grams of sodium chloride divided by 58.44 grams per mole, you get 0.034 moles. So 2 grams of sodium chloride has 0.034 moles. Number of moles is equal to mass in grams divided by the molar mass of that compound. Let's look at an example, which is a titration experiment. Right? Now, in a titration, 25 cubic centimeters of 0.1 m sodium hydroxide, moles per liter is the molarity, so 0.1 m sodium hydroxide solution is exactly neutralized by 20 cubic centimeters of a dilute solution of hydrochloric acid. Calculate the concentration of the hydrochloric acid solution in grams per liter. To solve this problem, we go through the following steps. The first step, we shall need to calculate the number of moles in sodium hydroxide. Okay? Because we have the volume of sodium hydroxide and the molarity. So we can get the number of moles of sodium hydroxide. Number 2, find the number of moles in hydrochloric acid by determining first the mole ratio from a balanced chemical equation. So step number 2, you write a balanced chemical equation between the two reagents, and then from that you can get the mole ratio. Then number 3, you calculate the concentration of the acid in moles per liter. That is the molarity of hydrochloric acid. And finally, you will be able to calculate the concentration of hydrochloric acid in grams per liter. Let's begin. Number of moles in sodium hydroxide is equal to the given volume in liters times its molarity. Alright? So the volume given here is 25 cubic centimeters of sodium hydroxide. You see, 25 cubic centimeters of 0.1 m sodium hydroxide. So to find the number of moles in sodium hydroxide, you take the given volume divided by 1,000. It has to be volume in liters. So you divide by 1,000, then times the molarity of sodium hydroxide. You will get 0.0025 moles. Okay? Next, we write a balanced chemical equation between hydrochloric acid and sodium hydroxide. If we do that, we shall get sodium chloride and water. So this one is balanced, right? The number of atoms on the right hand side is equal to the number of atoms on the left hand side. So from here, we can deduce the mole ratio, which is 1:1. 1 mole of hydrochloric acid reacts with the 1 mole of sodium hydroxide. From a balanced equation, you have to write the equation and balance it. From there, you will get the mole ratio. Alright? Now, after getting the mole ratio, we know how many moles of sodium hydroxide were used. There were 0.0025 moles. And because the mole ratio is 1:1, it follows that the number of moles in hydrochloric acid is also 0.0025 moles. Next, we want to find the concentration of hydrochloric acid in moles per liter. That is the molarity of hydrochloric acid. Now, in this case, we know that 0.0025 moles of hydrochloric acid were used. Therefore, the number of moles divided by the volume in liters. Because the volume used for hydrochloric acid was 20 cubic centimeters. So, we take this volume, we take the moles of hydrochloric acid divided by the volume in liters. So these moles divided by 20 over 1,000. You will get 0.0025 divided by 0.02. You will get 0.0125 moles per liter. This is the concentration of hydrochloric acid in moles per liter, or the molarity of hydrochloric acid. Next, let's get the concentration of hydrochloric acid in grams per liter. Cubic decimeters just means 1 liter. So this is the concentration of hydrochloric acid in grams per liter. Now, the concentration of hydrochloric acid in grams per liter is equal to the molar mass times the number of moles. Okay, we shall be able to get the the molarity of this acid in grams per liter. Now, the molar mass of this acid, HCl, the atomic mass of hydrogen is 1, chlorine is 35.5, so the molar mass is 1 plus 35.5, you get 36.5 grams per mole. Alright? So, the concentration of hydrochloric acid in grams per liter is equal to 36.5 grams per mole times the number of moles, which we found to be 0.125. So this times this, you will get 4.56 grams per liter.